Tell me what is Newton's third law of motion again. So let us recap it. If you recap it for several times, you can remember it easily. Tell me what is Newton's third law of motion, Sahas? Sahas,
Yes, sir.
tell me Newton's third law of motion again. Repeat it.
Sir, every action has an equal and opposite reaction.
Very good. Every action will have an equal and opposite reaction. Now that to be applied to prove what? Conservation of momentum in this particular case. And to prove this, you have to understand which is action and which is reaction, isn't it? And to understand about it. Now observe this particular system here. And what is happening here? Tell me what is happening in this case. Arnav, tell me what is happening here.
So
Arnav,
the system collides with each
right.
other.
Two objects are colliding with each other, isn't it? Two objects are colliding with each other. And when the two objects are colliding with each other, observe carefully. Object A is there. That means first object is there. This first object will apply some force on the object B. So force, sorry, some force will be applied by object A on B. So you have to understand like this, force on B due to A. So if I'm thinking FBA as action here, then definitely what happens is, in turn, this particular B object also will apply some force on the B. That will be reaction actually. So that means here, what I have to write now? FAB. That means force on A due to B. This will be what now? Reaction. Action and reaction. So here action is there and reaction is there. Again, in this collision, what will happen is A will apply force on B. In turn, B will apply force on A. And applying force on the B by A will be action. And applying force on A by B will be reaction. And maybe you know that what will be the Newton's third law of motion? For every action, what will be there? There will be an equal and opposite reaction. So that means action definitely will be equal to minus reaction. So what I have to write here? Force applied on object B by A. If it is action, what will be reaction? Force applied on A by B, but it will be in a reaction. Sorry, it will be in opposite way. So minus FBA will be equal to FAB. So now to derive this particular law of conservation of momentum equation, you have to derive or you have to write the value of FBA. You have to write the value of FAB. Now tell me what will be the FBA value. Tell me, Arnav, what will be FBA value?
M1U1 plus M2U2.
FBA means what? Tell me in your words, sir. What is FBA?
Final initial momentum.
F, see here. Understand carefully. I am writing here F. F means what?
Force.
Force. Force acting on which object?
The mass.
Force acting on which object? I wrote here clearly. FB I wrote. B means what? It is
Ball.
acting on B actually due to what? A. Understand carefully. Both the objects are there or not? How many
Yes, sir.
objects are there here?
2.
Two are there. A and B are there. Isn't it? First, A will apply some force on B. In turn, B will apply some force on A actually. So that's why to understand in a easiest manner, we are writing like this. B first, whatever first letter is written, force is acting on that object. But due to what? Due to A. So that is second letter that will denote the second letter. So try to understand here. FBA means force acting on object B due to A. And tell me what is the force equation generally? What is the force equation generally?
Force equals to MA
MA.
or
M means
MG.
what? Mass. A means what?
Acceleration or acceleration due to gravity.
Acceleration due to gravity will be there. If acceleration due to gravity is there, it is a weight. Remember, mg means weight. But you have to say only acceleration. Don't forget, always don't use acceleration due to gravity. Whenever weight is required, there only we use acceleration due to gravity. But here you have to use only acceleration. Is it clear? Arnav?
Yes, sir.
Right. Now tell me what equation I have to write. MA, no?
Yes, sir.
Right. MA. Okay. MA. What is M? What is A?
Mass and acceleration.
Right. Very good. What is acceleration? What do you mean by acceleration? Okay. Let me write that equation also to
Rate.
understand clearly. M into A means maybe you know that the rate of change of velocity will be known as what? Acceleration. So can I write like this? M into V minus U by T. Can I write like
Yes.
that? What is V?
Final velocity.
Very good. What is U?
Initial velocity.
What is T?
Time taken to achieve that.
Right. What is M?
Mass.
Very good. Okay. M is mass, V means final velocity, U means initial velocity, T means time. Now what is T here? Time of interaction. Now here you know that in the system what happened? Collisions occurred. Suppose two bodies are there. Two bodies are moving in a same direction like this. Two bodies are moving in a same direction. One is moving slowly, other is moving fastly, and it came and collided with this. And after collision, again they are moving in a same line. Now we are learning only about one-dimensional collision only. This is collision in one direction only. That's why it is called one-dimensional collision. And in this one-dimensional collision, what you are learning first? This is object A, this is object B. A object is coming and hitting the object B, and some force is applied by object A and B actually. So when you apply force, when system A is applying the force on B, there will be change in momentum of second. That means B object or A object. Arnav, tell me whether there will
B.
be change in momentum of object B or object A now.
Sir, B.
Very good. Object B. That means you have to take values of object B only. No, all these values. Mass, initial velocity, final velocity, time, all these things, isn't it? Have you understood it? Here, what is the equation, general equation? M into V minus U by T. What is M? Mass of the object. Which mass I have to write? Whether mass of a second object I have to write or mass of a first object I have to write here. Arnav, have you understood here? Which mass I have to write? Whether mass of a B object I have to write or mass of a object I have to write. Are you there, Arnav?
Yes, sir.
Right, tell me. Mass of which object I have to write? Sahas, you can also give answer.
Sir, I don't.
Right, tell me Sahas. Mass of a second object I have to write or mass of a first object I have to write? Sahas, tell me.
Sir, I'm not sure. I don't know.
You're not?
Sir, I don't know, sir.
Here, listen carefully. Force applied by A on B actually. Isn't it? When force applied by A on B, there will be change in momentum of B actually. So that means momentum of a second object will change. And when momentum of a second object is changing, we have to take mass of a second object m2 into v means what here? Final velocity. And final velocity of the second object is what here? v2. Here I wrote. Here you can understand here. v2 is a final velocity, v1 is a initial velocity. So that only we are writing here. So v2 is a final velocity of a second object minus initial velocity of a second object is what? u2 by in how much time it is occurring? In a time t it is occurring. So m2 into v2 minus u2 by t. Now this is actually force applied on B due to A. I'm writing this as equation number 1 and I'm treating it as action. Then reaction also will be there, no? What is reaction here? Reaction will be nothing but FAB. That means force applied on object A due to B actually. So tell me force on A due to B. That means there will be change in momentum of which object? Object A. So when there is a change in momentum of a object A by the B, then you have to write like this. I'm writing first general equation m into V minus U by T actually. So now I'm writing m means mass of the first object, which is m1. Final velocity of the first object is v1 minus initial velocity of the first object is u1 divided by t. So which is equal to FAB. So m1 into v1 minus u1 whole divided by t. So I'm writing it as equation number 2. Now tell me what is the equation number 1, whether it is action or reaction. FBA will be action or reaction.
Action.
Very good. What is FAB?
Reaction.
Right. Now what is equation form for a Newton's third law? What is the equation form for a Newton's third law?
M2 V2 minus U2 upon T equals to whole minus M1 V1 minus U1 upon T.
Very good, very good. That means you have to say like this. Action will be equal to minus reaction. So that we have to write here. Action value we know. Action value is given by equation number 1. Equation number 2 gives what? Equation number 2 gives what? Reaction. So action is there, reaction is there. Action will be equal to minus reaction. Already you know that according to Newton's third law only we are writing. So let us substitute action and reaction in a Newton's third law, which is nothing but action will be equal to minus reaction. So let me write here. So here we are writing action is equal to minus reaction. That means FBA is equal to minus FAB. So let us write down the values of them from these equations. So first, what is there? First equation is M2 into V2 minus U2 divided by T is equal to M1 into V1 minus U1 by T. Now, as T is common on both sides, we can cancel it. So T will be cancelled. And after cancelling, what terms are there? Let us write down them. M2 V2 minus M2 U2 is equal to M1 V1 minus M1 U1. How I got these values? I multiplied M2 with V2 and U2. I multiplied M1 with V1 and U1. So we got this value. Now what I am doing is I am writing all 1 values one side and all 2 values one side. So if I write like that, what I can write. So let us observe it. Okay. Now, sorry, all V's one side, all U's one side we are writing. Okay. Now if we write like that, what happens? So let us try to observe it. And here you are not saying one thing. Here minus is there,
So
no?
we have to whole minus it.
Right. So here minus and this will become plus. Isn't it? Whole minus is there, no? Here. Right, Bhumika. If it is minus, first minus M1 V1 and minus into minus plus. So plus will be there. Right. Now we will write all V's one side and all U's one side. Okay. Now if we write like that, what will be there here? M2 V2 as it is I am writing, and M1 V1 this side I am bringing, so it will become plus as I am bringing it from right side to left side. So M1 V1 is equal to, here already M1 U1 is there, so M1 U1 plus, if I bring this M2 U2 to this side, left side to right side, it will become plus, so M2 U2. So now observe carefully this equation. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Whether the equation which we have here is there here or not? You got it or not? Arnav?
Yes, sir, we got it.
Right. What is the equation again which we got now? Tell me. Tell me what we got. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Tell me what is M1 U1 plus M2 U2? M1 U1 plus M2 U2 is nothing but it is the
Fine.
total momentum of a system. Initial momentum of a total system. And what is M1 V1 plus M2 V2? It is the final momentum of a total system. So initial momentum of a system will be equal to final momentum of a system. That means momentum is changing or momentum is not changing here. Momentum of the system is changing or momentum of a system is not changing. Sahas, momentum of a system is changing or not changing. Sahas or Arnav, anyone can say whether the momentum of a total system is changing or it is not changing according to this equation.
Sir, it is not changing.
When it is not changing, can we say conservation?
Yes, sir.
Right? Generally, you know that just now only you only said what you said. Conservation of energy means what? Energy neither be created nor be destroyed, but total energy can remain constant. As total energy is remaining constant, in same manner, what will remain constant? Momentum also will remain constant in a particular system. And this is about conservation of momentum without any external force. If anything is happening in between two objects or anything is happening in one system, then momentum of that particular system will not change. How much initial momentum is there for the system, same momentum will be there for a system. Final momentum will be there for a system. So initial momentum of a system always will be equal to final momentum of a system. So this is about conservation of linear momentum, and this is generally the application of a Newton's third law. And how we proved it? We proved it by using only Newton's third law. Where we used Newton's third law, action will be equal to minus reaction. So based on that only, we derived it. So this is a very, very important thing related to the Newton's third law of motion, and you have to remember it. And again, tell me equation form for a conservation of linear momentum. What is the equation form for a conservation of linear momentum? Arnav, fast. Tell me what is
Yes,
the
sir.
equation for a conservation of linear momentum?
Sir, M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2.
Very good. So M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. And whenever you want to derive either V1 value or V2 value or M1 value or M2 value, now generally in your examinations questions will be given based on this. That means numericals will be given based on this, and in that numerical generally they will give three physical quantities. That means either M1, M2, V1 will be given, and they will ask you to find out V2. Can you find it or not? Can you find by the using this equation or not? Arnav, M1
Yes,
known for us,
sir.
M2 is known for us, V1 is known for us, and they asked you to find out V2. Can you find out by writing all the values into this equation? Definitely,
Yes, sir.
isn't it? So any three values will be given, and they will ask you to find out fourth one, and you have to find out it. And such kind of a problems are there at the end. You have to solve them by using this formula. Okay, and you have to give answers to me after solving that particular question. Okay, is it clear now? In this particular case, what will be law of conservation of linear momentum? Or no, is it clear or any doubt is there still?
No, sir.
Right. So this is about conservation of linear momentum, and you have to understand whole the equation like this. And here you are saying about collision. Do you know what you mean by collision? Before the collision, how much momentum is there? After the collision also same momentum is there. That's why we are saying momentum is not changing. It is remaining constant. So we are saying momentum is conserved. But what do you mean by collision? Can you say? Which is called collision. In collision, what happens? Collision means what?
So when two objects collide.
Okay, I am asking collision, so you are saying collide. Collide means touching, no, generally.
Yes, sir.
Collide means touching. Those two are moving and touching with each other, and after that, they are moving. But actually, collision in physics means if any process can make change in momentum of the objects, then that particular process will be called collision. What that process will be called? Collision. That means it has to change the momentum of the objects. But remember, total momentum of the system will remain constant, but momentum of objects will keep on changing. Maybe first object momentum may increase, and at the same time second object momentum may decrease. So like that, if there is an increase in momentum of a first object, there will be definitely decrease in the momentum of a second object to make that particular total momentum constant. So that is what you have to understand. Any process or any event in which there is a change in momentum of objects, then definitely that process will be called collision. And why I am saying is, sometimes few experiments will be there. In that experiment, without touching also, even though no touch is there, then what happens is momentum will change. That also will be treated as a collision only, even though they are not touching with each other. That's why I said here. Okay, maybe I hope you understood related to conservation of momentum, and in a simple words, not to understand all these things, in a simple words, you have to understand like this. In a system, if any collision is occurring, before collision, how much momentum is there for the system? Same momentum will be there after collision. So this thing you have to remember, and in equation form, you have to remember like this: m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this is about law of conservation of momentum.